Hello, hello, hello. Something wrong with my camera. Okay, finally. I think I should be visible and you all can hear me. Hello and welcome back. Can I get a quick ping on the chat if you all can hear me, please? Anyone, please, would be really helpful. So you all can hear me. Perfect. Can you hear me? Can you hear me? Can you hear me? Good morning. All go. Perfect. Awesome. Thank you so much. Okay, let me just can remove these banners. Hopefully, you all have checked into the event. If you have not, uh, here you go. The link to check in. This is part two of our hosting a website using ESP-32. Even though we have not reached the website hosting bit yet, but that's fine. Okay, we did a bunch of stuff. I am trying to see if there is any other banner. Okay, perfect. I think I have the system up and running. Cool. Excuse me. So, welcome back, everyone, after the break. Hopefully, you all had a nicer break than I did because I was just trying to ensure that the README is better formatted. And also, if there is anything, my webcam is off. Can you all not see me? Interesting. Well, as per this system, it is on, so which is very weird. Let me just reload and come back. Maybe that will help. Can you all see me now? I hope you all can see me now, and you all can hear me now. Uh, as per as per StreamYard, my webcam was on, uh, but I think as per Twitch, it wasn't. It wasn't streaming it. Very weird. Anyways, technical issues aside, hello and welcome back, everyone. And I'm so sorry that you were not able to see me before. And yeah, as I was saying that hopefully you all had a nicer break than I did. I was just trying to ensure that all the commands are actually up and running properly. So I made teeny tiny bit of changes in the README. So nothing with respect to the commands. I just formatted it nicely. So this was the previous format. This was like not really nicely formatted, and there was just too much in this bit. So I have kind of broken it down into like its own segments, its own pieces. So there is the flashing bit where you replace it with your file path downloaded, the link to download with the proper naming right there, and sample output explanation of the command, which is what we use for flashing. So I told Copilot to write this, and this is what it gave me. And I think it's mostly correct. I made two tiny changes, but otherwise it is perfectly fine. Uh, as even this is what I understood even in general. And to verify the installation, this is what you can do. I did write one thing here, which is like sometimes. So if I try to, for example, if I just zoom in a bit, clear this, and I try to do. connect to the REPL session. Okay, should have googled that. I don't see those three greater than symbols. Okay, so to reach there, what I have to do, or at least this is what I tried doing a couple of times, and I realized I have to do Control A, which makes me reach this raw REPL, and then I do Control B, and then I finally reach the actual REPL bit. And here I can just do whatever I want to type. Example, I can say print this thing, and I can paste it, and there we go. So all of this running inside the ESP32, and to exit I can do Control X or even Control and square brackets. Both of them work. So if I do Control X, there we go. I have exited from the REPL and I've come back to my own system. When I'm inside the REPL, this is happening inside ESP32. When I'm outside of the REPL, you can see it says this whole, how much time I was inside that system. 50 seconds. Nice. So as like right before this, I was literally trying to just push this on GitHub. I am going to amend the commit. So git commit dash dash amend, so that it is part of session 1 itself rather than session 2. And since I have amended the commit, I'll need to do a force push. So what does it mean by amend commit? It will mean that I'll still have only 3 commits, but this bit would have changed as soon as I record. As you can see, only 3 commits, but a better visual output in the readme, okay, of what to do, how to do. Okay, short description. Interact with ESP-32. Okay, cool. Uh, okay, I again, for folks who are just joining me, let me give you a quick overview slash recap of what we are doing slash we have done slash what am I aiming to achieve. So first of all, here is the GitHub repository. You can keep this in mind. Oh, someone started. Thank you so much. Appreciate that. Okay, so keep this handy because everything that we will do as part of the next 3 sessions, so this session and 2 sessions tomorrow, uh, all these everything that we do will be on this GitHub repository as either the README or the code or whatever we do. What have we done so far? We have connected a ESP32 module, which let me just zoom in and show you. Wrong place, wrong place. Yeah, here we go. So this is a ESP32 module. Bought it for pound and 10 pence or pound and 20. I still have to go search like my buying history there. I bought like two so that because it's cheap and uh, I can destroy one while I was practicing for this session. I was like, what if I destroy one? I will need a backup. So I got two of them. And yeah, we are trying to create a project where we will host a website on ESP32, where ESP32 will act as a web server. And when I mean a web server, think of it as a cloud system. Think of it as Netlify. Think of it as AWS. Like we'll make our ESP32 a very, 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 very miniature version of Netlify or AWS. Okay, or hosting a website. And this is not a unique project. I actually got this idea from this particular blog. So I'm trying to basically recreate that with maybe, there have been command changes since then. And also the idea would not be just to host a static page like this, but more like a portfolio website. And the uh, the next step on that project would be like you all can add your data and I will host it on my web server because electricity is comparatively cheaper uh, from other places. I can host it. This was from my previous stream, so remove. Okay, come back to this one. Cool. So yeah, this is the idea of these sessions. In session one, we went over a bit of theory and we were able to install MicroPython on our ESP board. Okay, ESP32 board. We were able to install or flash it with MicroPython. And we verified it by connecting to the REPL of the Python that is running on the system. Okay, so that is what we have done so far. What else? Okay, I think that is good enough. Like overview of what we have done. I mm, okay. So the next bit that I'm going to do is let's start writing a very simple, teeny tiny bit of code which will allow us to or like to basically run this to control a LED. Okay, a very simple, very simple uh, piece of code. Good. So what we'll do, we'll write a small LED control code which will just blink the LED. And what is blinking? You turn on the LED, then you leave it on for like, let's say 500 milliseconds, couple of milliseconds. 500 milliseconds is what I was going for. Then we'll turn it off, and again we will have a pause of couple of milliseconds. So like let's say again 500 milliseconds, and we will keep doing this in an infinite loop. Okay, so yeah, that is the basic program that we will write. We will write this program. We will upload it on this ESP32. I need to keep like zooming in, zooming out, but ESP32. And then I will zoom in on my cam and we will see uh, it basically doing that blink program. Oh, one last thing that I want to tell you all is like for folks who are just joining me, that this would be a very beginner level session. Okay, so you might feel bored slash you might feel, oh, I know all of this. This is like too simple for me. I would uh, still request you all to stick around and help others who don't actually know about it. Okay. Uh, okay, there is a question because the word that is being used, I think it gets blocked. Uh, that's why it's not a visible question. But the question is, how much RAM does this have? Okay, RAM and ROM. So what you can do is quickly Google for ESP32 data sheet. Okay, this is what I was reading as well. I think I was reading this one. Yeah. And you can find out how much memory it has right here. So let me share this, excuse me, data sheet with you all. So data sheet is basically everything about this particular system. So what I talked about in session one, about how like what pins it has, what they can be used for, blah blah blah. All of that is basically available on in their data sheet. Okay, so I got most of that information from this data sheet. And to answer the question how much memory it has, how much RAM it has, it is also available here. I should go all the way to the top, and then if I scroll down, I can basically go to this one, CPU and memory. Okay, so it has 448 kilobytes of ROM for booting and core function, 520 kilobytes on chip SRAM for data and instruction, 8 kilobytes for SRAM in RTC, which is called RTC slow memory, and there is 8 kilobytes SRAM in RTC for RTC fast memory, 1 kilobyte eFuse, and the external is 16 megabytes. Okay? External flash memory. So we would be using this one, and up to 8 megabytes of external flash for CPU data space. And okay, cool. And that memory address thing that we had done, it comes from this. Okay, 0 1 0 x triple 0 1 2 0 or something like that. Okay, so they are the memory spaces or the address of where that space is. Memory address is nothing but here is a space, or this is the address to a box where you can store data. Okay, that is what a memory address means. Think of it as your normal home address. And yeah, here we go. This is how much space or RAM, ROM it has. And how can we club this Arduino Mega? If I remember it correctly, and actually Google will correct me if I'm wrong, but I think Arduino Mega already has Wi-Fi. Okay, yes. So some Mega boards come with ESP-8266, which is basically the Wi-Fi module itself. Okay? Uh, so ESP-32 is ESP-8266 plus extra space. ESP-8266 is the actual kind of chipset which connects to the Wi-Fi. And some of them actually come with Wi-Fi, so you don't really need to connect ESP32 with with Mega. Okay? Like not really needed. So confirm if the board that you have, if it supports Wi-Fi. Uh, some of them do, some of them don't. Okay, if it doesn't, then you will need to connect the ESP32 with Arduino Mega. And I think a quick Google search should help us. Let's try Arduino Mega with ESP32, like the one that I'm using. And you can use the serial communication that we talked about. Uh, and you can connect them using or ESP8266. I think you can connect that. Remember all the ports that we were talking about? I think this is the best time. So TX0 or TXD, transmission, receiver, TX0 and RXD, transmitter and receiver. Okay, I think there is a way to connect it, and quick Google search helped me out here. Though I am not sure. I don't have a Mega, so am actually not able to try it out. Unfortunately, really sorry about that. Uh, but I think it should be possible. And you don't really need ESP32. I think 8266 should do the trick. So this is the built-in one. But it looks possible via some wire connections, like which wire goes to which part of Mega. Arduino Mega receiver, node MCU ESP12, and you need one for transmission, one for reception, and one for transmitting data UART. Okay, yeah, looks possible. Uh, and the AI overview actually tells you, okay, this is what you need to do. Wire the grounds and the power, then connect the TX pin of one board to the RX of the other for serial communication. And that's it. TX to RX, transmitter to receiver, power, and ground. These three should do the trick. One, two, three, four, five, six. It connects six pins. What else does it connect? The power of connect the ground pin of ESP8266 with the ground pin of Arduino Mega. 3.3 volt of ESP8266 with 3.3 of Arduino Mega, and TX with ESP's RX, and ESP's TX with Arduino's RX. So that's four pins, one, two, three, four, and voltage divider in between, so that, yeah, so that it doesn't damage ESP8266. That's why five pins. No, that's still five pins. TX, RX, one, two, power and ground four, and voltage divider five. That's it. I don't know what's the sixth one for, but you can watch this particular video. I think that's helpful, right? Cool. Uh, and other questions, in a real server environment? No, definitely not to, let's say, power Facebook. Okay, if you want to run Facebook on ESP8266, it's a bad idea. But for simple programs, yes, it is possible, and yes, it is because of the RAM and ROM. Okay, so it doesn't have enough capacity to run all of it. But I can tell you what does have the capacity: an RPi, a Raspberry Pi with 8 gigs of RAM or 4 gigs of RAM should be good enough for like 95% of the use cases. Okay. And you can also kind of connect them together to have a proper server setup, okay, where you will have like four Raspberry Pis connected with each other, sharing the load, and you can do a bunch of things with that. I think it's pretty epic. Okay, cool. That's enough about everything with respect to this. As you can see, I get very excited about hardware because I think it's pretty cool. Like you can communicate with it and you can do a bunch of things. Okay, moving on to the next bits. Do, 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 do. Okay, so the next thing that I want to do is the LED blink LED program, right? Yes. So before I forget, let's quickly do that. So what I'm going to do is let me create a excuse me blink.py. Okay. So this is a blink LED program that we are going to write, and this one, let's try it out. So from machine import pin. Okay. Now machine is going to be installed on uh, in the MicroPython that we have flashed. So that should be good enough. Oh, sorry. There is one question which I want to answer before I go ahead. What are the real world scenarios to run web server over embed? Uh, Something very small like ESP32, nothing, frankly. I can't think of anything other than if you have your own mini setup. Okay. Example, I think the other day, if I remember it correctly, someone on Twitter had posted that they were using Zerodha's API, which is a trading platform, their API to power a bulb in their on their in their house, and every time the stock that they had invested in goes down, it would flash red. Every time it goes up, it would flash green. uh, Now this whole setup, you can connect ESP32 with zerodas APIs, and you can connect ESP32 with this bulb or LED in this scenario, like an LED or a bulb in this scenario, and we can leave it running somewhere, right? So a fun little project, uh, I guess, is one of the answers to your question of why would you have a web server running over embed. Not in this case, it's not really a web server; it's more of a server uh, yeah, running over embed. But just an example, for Raspberry Pi, you can have like a multitude of things. Like if you have seen my previous projects on this, I have this color palette generator project. I have a WebSockets auction platform project. I have some mini projects. Theoretically, I could run all of this on ESP32. I have this web song maker project. All of these are hosted on currently hosted this Doodle platform. Okay, all of these are currently hosted, and theoretically, again, I could not host it on an external provider's systems. I could have my own running because I know that it's not getting a lot of traffic. Okay, I think it has barely anyone actually visiting one of these days. So this is one project, then this is the other project, and then this is the other project. And I think I can do lean dot so dot com and yeah. Doodle platform, 0 people visiting. Color Conjure had these many visitors over the time. Web Song Maker, 3 people visiting. Okay, cool. So not much. Okay, right? Not much, and I have it running on Netlify. Not really needed. I can technically, theoretically run my own system, my own server, because I know the maximum it would happen is 500 people will visit these websites in a year. Okay, that is the maximum. That's like wow, amazing, kind of. And this is like 3 websites combined. So again, a scenario where you can run a web server over embed systems, over microcontrollers. Okay. Uh, Hopefully that gives some sort of answers. It's more like to test out, to experiment, to learn. That's the only scenario that comes to my mind of why would you run it over embed. Okay, going back to our piece of code. So very simply, let's try type this out. We will need time module again, of course. Not again. Wow, it knows basically most of it. Okay. Uh, cool. So this one will be installed as part of a MicroPython library already. I know that for a fact because I have prepared for this session. I don't come unprepared. So that's why I know that this will work out. And also what it is suggesting is correct. So most ESP32 boards, yes, this is true. So I can say LED, tell it to use the pin like function that we are importing from machine, and we will say that it is the pin out, and I will let's say okay, I'm just going to say starting. Okay, yeah, this is good enough. Starting LED blink program, and while true. Okay, let's see. So what has this written? It is saying that turn the LED on, but I don't think it needs a value here. Uh, 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 Let me see if I can install machine as a library. Okay. I think this is the link that I'm looking for. Okay, for its documentation. Let me also share it with you all in chat. There you go. So, this is not. Well, what do we have? Which version do we have? I'm pretty sure we have the latest installed 1.1.26.0. Okay, and we are looking for the pin module and class pin, and that's it. Okay. So, from machine import pin and create an output pin on pin 0. So we are telling it that on this particular pin, I want to make it a output pin, and you can create a input pin with a pull-up resistor. So this is you telling the code that the hardware setup is in this particular manner. Okay. So that's all we are doing in this case, pin out, pin in. And the LED blink program, so I can say micro Python LED blink ESP-32. I think I had found a piece of code which I just reduced a bit. It had too much. So I reduced it a bit, and where is it? Okay, so I can do something like this on the REPL itself, or I can write a program and upload it. Let's try and copy. I will set it to 0. Then no, this is 1. So to turn the LED on, we are basically saying the full value, use the full value. Then we are doing a sleep for 1 second here. And then when it is sleeping, so right before that, I can say, no, right after this, I will print LED is on. And right after this, I will say LED is off, and then we wait for a second. Instead of dot value, you can also do LED dot on. Yes, perfect. Awesome. And we can also turn it off by using LED dot off. Okay, so step one. Let's first try to do it in the REPL itself. Write this program in the REPL itself, and then we can upload this blink.py code over to our ESP32, if that makes sense so far. Let's do it out, and then it will make much more sense. I'll expand this. I'll also clear this out. Remove this bit so that you can focus solely on the code. I think the code should be visible. All we need to do is connect to the ESP32 serial. It is connected. Things I have to do: Control A, Control B, so that I reach this part where it has these three dashes. I am going to say from machine import pin. If I hit enter and I don't see an error, that means it was successful. Next was I have to do import time. So again, I hit enter and no errors. That's good. Next, I can say LED equals to use the pin that you have imported, the pin function, the pin method that you have imported. And on pin 2, consider it as pin dot out. Okay, it's an output pin. No errors so far. Next, we said let's start writing this. Okay, it is starting the blink program. Okay, and next up is I am going to do what this has done. While true, and I'm going to say LED dot value is 1, And I'm also going to print LED is on, and I'm going to give it time dot sleep, sleep for let's say zero point 0.5. Just 1 second is too much. Then I'm going to turn the LED dot value as 0, which means it is off. I'm going to print again. LED is off, and it will be off for again a few milliseconds. So point this is in seconds, so zero point 0.5 is 500 milliseconds. Okay. Anything else that the user has done? Nope. Okay. And now there we go. It has actually started. Let me show you on screen. Oops. Yeah. There is a blue LED which is flashing. It is on pin 2 and it keeps on flashing 0.5, 0.5. It prints it on the command line and it flashes here. And now this will keep on flashing. Okay, this will keep on flashing until I exit the program by doing Control C, and it stopped at what was the last thing, which was LED is on. It stopped exactly there. Okay. So works definitely, but now LED is on is what it is stuck on. Cool. So the program is up and running right there. I can exit out of REPL, but the program is still there on the system. Okay, this is what it stopped on, and it's still there on the system. Cool. Uh, so that is a very simple LED program that we have written. I can copy paste this, all of it, or actually, someone has already done so much. But then it will also have all the other details which you may not want because you've already done it. So let me start from here. And can I copy this? Yep. Go over here and I am going to create a blink.py.md. Okay. So this is blink.py code output with instructions. Yep. And this is perfect. Okay. So this is what we have done so far. This part is a bash command, and bash ends here. No, not here. I will say the bash bit, it ends here. And the Python bit starts from here, ends all the way to the bottom. And what did we do here? Uh, press enter a couple of times to start the program. This is not stop the program, this is start the program. And then it should starting blink LED is there, and here starts the blinking of the LED. Mm, Everything understandable? So this is what we did. Don't think I missed out on any part. Here we have connected to the REPL. So connect to the device using MP remote. Yep, that is true. Then we saw all of this as output. And okay, then in the Python, uh, start typing the following code in REPL one by one. So we wrote this. We wrote as soon as we wrote the print. Of course, printed that out on the screen. So that is cool. And then we did this bit where we are doing LED dot value like one, which is on, LED dot value zero, which is off, and we pressed enter twice, no, a couple of times to start the program. And this is when it starts the program, and you can actually notice the LED on is every half a second. Yeah, this is what happens. And I'll leave dot 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 here. Perfect. So this is all we did for blink.py.md file. The reason why I named it same as the program, because that's when you how you know or you will know what to do. Okay. The next thing that I want to do is I want to remove this bit, okay, and show you that you can also do it with the LED on and LED off. Okay. Let me clear this. Now, how do we upload the program over to over over our device? Okay. So step one, first let's see if there are any files on our device. So I can do yes, connect to this one, and instead of starting a REPL, I want it to list out all the files it has. Currently, it does have one file, which is boot.py. Okay, so boot.py is a file which already exists on the system, and yeah, what we can do is if I am right. Okay, yes, there we go. So I can print out on what is on the boot.py. We have not written anything, and right before this, like at the start of this these sessions, I had flashed the MicroPython. I had flashed ESP-32 with MicroPython library, so I did not do anything. This is what comes as default, and it says that this file is executed on every boot, which means whenever it wakes up from deep sleep, it tries to do this, but all of that code is commented out. It technically does not do anything. Okay, but this files is already by default on the system. uh, okay, so let's go back to our readme.md, and let me add a section on check files on the device. Oh, I did not try this one. Let me try it. I have no idea. Okay, it does the same thing. Uh, okay, print the files on the device, print the content of a file on the device. For example, this one is what we did. Uh, Let me give a sample output for this one so that you know what it actually shows. Okay, so this is a sample output, and this is what happened when I ran this particular command. So Again, sample output for this one right here. Okay, this is the exact sample output we got. Check the files on the device and read a file. Okay, yep, this is good enough. Okay, now how to upload a file. Upload a file to the device. Okay, let's try this one out. I mean, I don't use the fs command directly. I just go for, like, I don't use the fs command, which is the file system command. I just directly go for the cp, which is copy. Uh, okay, so let's do this. I'm going to clear it, and I'm going to say that MP remote is what we are going to use to connect to this device, and then file system, copy the file name over to the device and give it this exact file name. Okay, that's what this command means. So I am going to copy this, and it's done. Let's see how many files do we have now. We now have two files on the device. Okay, there's the boot.py and there's the blink.py, which means I can also read the content of uh, blink.py, right? And if I do that, this is what it prints out, which means that our file has actually uh, reached the ESP32. Perfect. So now how can I run it? That's the question you should be having. How can I run this file that I have just uploaded, right? Okay. Multiple ways to do it, of course. Multiple ways to do it. Uh, we can run the file from here. We can actually, let's very quickly try it out. We can do an execute on the file. So that is one thing. Like, you can do an execution of, like, oh, go to this particular path and quickly run this file. Okay. And when I say quickly run this file, I mean, like, just do a kind of execute. Or you can also do a very simple run and then the file name. Okay. So upload a file to the device, and I'm going to say, yep, run the uploaded file. Yep, perfect. So multiple ways to do it. Let's say we'll follow this particular. We first connect to it, and then we run the file that is on the system. And there we go. It is up and running. It's now taking a second. And let me command screen and show it to you. There we go. Okay. So it's taking a second, of course, because we increased it from zero point 0.5 to 1 second. And it is flashing and it is working. It is running everything. It is printing out everything. So I think it's good enough, right? Okay. Uh, so far, so good. Any questions, anyone? Let me also look at the chat if I've missed out on any questions. It works. And I'll leave it running. Okay, I'll leave it to flash right there. We have run the uploaded file and alternate ways. Let me see. Yeah, this is one way. The exact way. Let me find the. Hmm, okay, so this is another way. So this is basically saying that go in, like, connect to this device and execute this particular command. Okay, which is basically running a Python file. You can import the file which has gone over to the system and execute it by giving it some command. Now, using execute, you can do pretty much a lot of things, right? Example, you can delete a file from the system using, like, by importing operating system OS library and then doing os dot remove, for example. Okay, so that is one way to kind of uh, what do you call use the exec command. Uh, yeah. Other things that come to mind, don't think anything else. Okay. Questions that I had in the chat. Let me see. Okay, what would you suggest the graduate who will be what things we can start experimenting with? Depends on what your interests are, right? Now, this will be a bit of uh, what's the word? Uh, Preaching. Okay, this would be a bit of preaching, but just hear me out. Depends on what you like. Uh, Experiment with what you like. I like to work with experimenting with hardware, but this is my first time doing it in like 4 years. Okay, so after 4 years, I think I got the opportunity because of Global Hack Week that, oh, let's get hardware back and let's try it out. Um, I am an electronics engineer, so I should have been working with electronics, but I don't do that anymore, at least not in my day to day life, not at my work. So this was the perfect opportunity to try it out because I got given an opportunity as part of Global Hack Week that, hey, if I have to do a stream and I've not touched hardware like in so much time, this would be the opportunity to try it out. So that's how I would say what I like, and I got an opportunity to experiment with it. Depends on what you like. If you like game development, just give it a go. If you like just building websites, give it a go. If you like animations, give it a go. Find the perfect opportunity and just give it a go. The worst is you will fail. In my case, I'll also lose money, the pound, but it is what it is, right? If you have a software system, at least, okay, if I know that, oh, I want to give animation a try, a sketching a try, and I'm not good at it, I am worse at sketching, then it will not cost me much. I can just pick up, if I have, like, let's say I do have iPad, so I can pick up iPad and just sketch something. I can show it to my friends and they'll be like, yep, it looks so bad that please don't do it again. I'll stop. Right? So yeah, try to find out the things that you like and give everything a try at least once. That's the only way you will know what you actually really desire, in terms of experimentation. But make sure that you have two things completely separate. There's one thing which will earn you money, and there's other thing that you do as a hobby, and they could have an overlap, but sometimes they don't have an overlap. Okay, that's a life advice, I would say. Uh, could, couldn't, depends. Completely depends. Okay, cool. So that's a bit of preaching right there, and perfect. So I have shut the program, but it still keeps running. It keeps still keeps flashing. So we will need to write a bit of code where, I can kind of stop it when it is done, or when, I'd say, let me think, what's the best way to put it? When I exit the program, can I, in a way, set it to be false? Okay, so let's enhance this. Before we enhance it, let me push this so that you have at least one version of it, and then I will push it again, and you'll have another version of it. Things that I changed. Let me close all of this. things that I changed created this whole file. Let me add a comment here saying, perfect. See, these are the things that I like like all these LLM agents for. Takes away all the hassle of typing these comments. Again, depends on if you are writing the correct comment. Okay, sometimes it is just not that good. Uh, 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 hmm. Blink.py, I think this is what we did already. Readme, I think I should also quickly add a comment saying that check readme.md for more details on how to upload blink.py to your device. Uh, and I am going to just copy paste a few things from the README. So connecting is fine, uploading is fine, run the uploaded file. I think this bit can go there. Actually, just this whole bit. Uh, Run the blink.py using np remote, and I am going to paste this bit and I'm going to just close this. Perfect. So I think this is good. Run blink.py, check readme.md for more details on how to upload blink.py to your device. So that's good so that you have a reference to it. And this is the running bit. And that's good. Cool. Let me see how it looks on Markdown. So I'm going to do Command Shift P on my Mac and run it. And there we go. Details and okay, cool. And readme is good as well. Should I name all of these as file name.py, uh, file name.py, so that you know that it is not exactly. Okay, cool. I think these details are good. Now let me just push this. So this is session 2, part 1 of our Blink program. So get status, okay, get add all, get commit. I'm not going to amend this commit. This is session 2 blink.py part 1 and git push. I don't have to do a force push. This should be good enough. Let me quickly take a look. I mean, if it's pushed, it should be uploaded here, but just in case. And details, and yep, that is good. Perfect. I think this is good. And let me once again. I know I say share it like too many times in the chat, but I just don't want you all to lose it, uh, lose the access to it in a way. Perfect. And blink.py.md. I don't like this file system. Hmm, okay. Because blink.py.md on my system is right after blink.py. So I would have presumed that it would be right after on GitHub as well. But I think GitHub has all capital K, like uppercase and smaller case, have different way of ordering. So I'm going to rename this to blink.py.md. Again, just so that they are together. So that when you are looking at the piece of code, you're like, oh, There is the instruction, there's the instruction. And I am going to amend my previous commit, unfortunately, just so that I don't have multiple commits. Okay, GitHub doesn't like it. They're like, I don't think anything changed. Blink.py.instructions.md. So uppercase and lowercase, Git doesn't differentiate. GitHub doesn't differentiate. They're like, same thing. Okay. Git add, git commit amend. Sorry, I am being too peculiar about this, but I know for a fact this will be helpful when you look at it later. Yeah, see, now this is much better. I feel. I feel being the keyword here. Okay, cool. The next bit, as I was saying, like we can enhance this, but looking at the time that I have, I would not want to do that right now. Okay, what I would want to do is show you how to connect to Wi-Fi. Okay, connect to Wi-Fi using like, multiple ways. I'm going to go for the easiest one. Okay, the easiest one where I can show you that hey, this take this piece of code, run it on your system, scan for networks and scan and like kind of not scan, let's say connect to Wi-Fi. Okay, so enter your ID, password, and connect to Wi-Fi. I want to do the scanning bit rather than like we can have two things. Okay, we can have the ID and password predefined and it will connect to the Wi-Fi, or we can have a way where we can do this whole let's scan for Wi-Fi networks. Let's connect to a Wi-Fi network by entering the ID and the password, SSID and password, and then let's see if it is actually connected or not. So we can like I prefer to go that way. Cool. Uh, before we go that way, any questions, anyone? Okay, I'm going to take the silence as golden, and I'm going to presume that there is nothing that is needed, like no questions from anyone, and let's do it. Okay, so to write the code. Let's start writing the piece of code. I am going to create a Wi-Fi underscore connect dot py file. So this is where we will write our Wi-Fi connection, and I knowing uh, Copilot, I think it will understand what we need to do. Ah, yeah, there we go. But I'll still prefer to write bits and pieces. Network, I am going to import that. I'm going to import time. All of these come from MicroPython library. So I can search for network and you can see, here we go, network. And connect or show the IP config, a specific network interface, a lot of things right here, import network, driver, blah, blah, blah. Since I've done this, so I know what piece of code to write. I Googled it a lot. I had asked LLMs as well. So, and I was like, okay, this is too much. Can we reduce it and also make it interesting at the same time? So I have that interesting bit with me. I'm going to use that to show you all how to have this a really nicer looking output. So def, I'm going to say scan underscore networks. Okay. So what are we going to do? We are going to write a piece of code which will scan for all the available Wi-Fi networks in the range of my ESP32, and it will return me a list of nearby Wi-Fi access points with signal strength. Okay, so how close apart am I? Uh, so the signal strength will tell me, oh yeah, this is very close to you, perfect to connect, or hey, this is very farther from you, don't connect to it, like weak signal. Okay, so I'm going to say WLAN equals, let's say, wow, it starts writing everything. So it's at one point I'm like, do I really need this? Network dot WLAN, and I'm going to say network dot STA underscore IF. So STAIF is station interface, which means it will connect. Sorry, excuse me. Station interface, which means it will connect to existing Wi-Fi networks. And you also have APIF, which means access point mode, where your ESP will act as a Wi-Fi. Okay, so we have two options: uh, STAIF, station interface, which means connects to a Wi-Fi network, and the other one is APIF, creates a Wi-Fi network. Yeah, perfect. Awesome. This is what I like. So in our case, we want to connect to an existing one, okay, which is Wi-Fi that my computer is currently connected. So I am just going to do that WLAN dot active true, which means that here we are activating the Wi-Fi hardware. Okay. So if you don't activate it, then you can't scan for any Wi-Fi networks, right? Let's do some awesome scanning for available Wi-Fi networks. Just being picky again. And okay, to scan, there we go. Dot scan. So this will perform a network scan, and it will return SSID, channel security, a bunch of things. Okay. Now I can say for, actually, let's just also print this out. So what are available in networks? Actually, awesome. And uh, okay, yep, this is nice. Okay, so I'm going to print dashes 50 times uh, after this. So that's what I'm doing. And let's now display all the networks that we have. Uh, wow, this is a lot of things. I am not going to do all of this. I am just going to simply be like print, not print. Let's go for I, comma, net in enumerate networks. Okay, let's take this first and then let's read it. Okay, so what am I doing? First of all, I am trying to get the SSID, or basically this is the Wi-Fi name. And I need this? I have no idea what this means. All I care about is RSSI. So I don't need all of this. Remove this. And okay, next one is RSSI. This is the signal strength. It is in dBm, I think decibel, not decibels, I think decibels, yes. And it is a negative number. Okay. Then, excuse me. Next, we can have a auth mode. This will tell us whether it is a secure network or not. Like, does it have an ID password? We can use emojis if you want. We can do a bunch of things. Like, you can show a lock to say yes, it is. A lock network, or like needs ID password, or you can show an unlock icon to say that, oh, it's an open network, anyone can connect to it, kind of. Okay. Uh, okay. I don't need BSSID. I don't need this because we are not printing all of that. And yeah, this is what I have. Perfect. So I am printing out the SSID. I am printing out the RSSI, which is the signal strength. I am printing out whether it is a locked or an unlocked network. So it will print out zero. Uh, it will print out values. It will print out some numbers. And we are also printing out if it is hidden or not. But actually, don't really need this as well. I think just this much is enough. What am I missing? Perfect. So this is the bare minimum that we have written, and I can basically go outside of the for loop and I will say, yep, exactly this, and we can return the networks. Okay, so I am, how much time do I have? Not much. So let's run the scan bit uh, quickly. Yep, this is what I want. I can say print Wi-Fi network scanner, and I can say print uh, okay, dashes, or just let's say stars. Mhm. Or let's be smarter. We know that a string multiplied by some value will print it that many times. And now I'm going to say print. Uh, you can run scan underscore networks, find available Wi-Fi networks. Perfect. Okay, this is good. So Wi-Fi network, Wi-Fi connector. And for now, we have written just one of it, scan networks, which should scan the network and give us some output. Okay. Let's say if it is good or bad, like at least is it understandable or not? That is what we want. That's the most important bit, and everything else should be fine. Okay. So let's do what we did before. To upload a file, what do? We do fs ls. Uh, Where's our instruction guide? So I will keep referring to instruction guide, even you should keep referring to the instruction guide. Uh, so step one, let me see which are there are two files there, boot.py and blink.py, which is fine. I can, how do I upload it? I have to do fscp, the name of the file. So in this case, it is wi-fi underscore connect.py, and it should be the same on my ESP32. So I'm going to copy uh, this the contents of this file over to this new file that will be created there, and it is copying, and that is done. Now if I ls, perfect, there are three files now. Okay. How do I run a file? I can do mp remote connect and then space run space wi-fi connect.py, hit enter, and it stopped. Whoops, that is not good. uh, it stopped because, well, I did not actually do anything about it. All I did was I did not even call the function. So let me not waste any time. I am going to just do this, right? I'll have to copy it over again. Okay, still 3 files, but now it has increased in size. And run it and scanning for available Wi-Fi networks. There we go. Perfect. So it has got all these Wi-Fi networks which are around me. Okay, all these Wi-Fi networks which are around me currently. Uh, these are running right here. Okay, this is good. Now my Wi-Fi is this one. Okay, SSID. Signal strength is -51. Uh, Good enough. Auth mode is 7. What does that mean? That means it needs an ID and password. As I said, there will be numbers here which don't make much sense. It The ID password also tells you whether, like, which type of security it has. Does it have WPA security, WPA2 security, and other options that are available? These are the only two that I know of. Uh, so we can kind of enhance our function. Oops. Oh, well, there we go. Hmm. I can say for auth mode, we can show a lock. It has a lock and key. Uh, if the net of fourth is more than 0, else we can show unlock. I don't know if there is something for unlock. Uh, Open. Okay, I can show this icon. Okay, so yeah, all it does, it shows this icon lock and key is required if it is greater than 0, which in this case is most of them, and else it shows this, which means it is an uh, open network. Okay, cool. So we can enhance the scan that way, scan the network bit that ways. Let's write a function to connect to Wi-Fi. Okay, you can say yes, you require SSID and password. So these are the inputs, and I have no idea what it did right there. So this, and I'm also going to give it some timeout. Okay, cool. So what am I going to write here? How much time do I have? 20 minutes. I think that should be good enough. So WLAN equals, yep, we are connecting. Okay, let me just take this piece of code and let's read through it. So WLAN network dot WLAN network dot star STAIF. So we are connecting to it. We are enabling the Wi-Fi hardware. So these two lines are known. Then if we are already connected, then in that case we'll do an early return where we will say that you're already connected to the Wi-Fi network and return true. Okay, which means you're connected and you don't have to do anything. We are early returning. We can, if you want, we can enhance it. Already connected to a Wi-Fi network, we can use the F strings, which means you can add some. Yeah, perfect. Or actually, there is also one thing called as. They should tell me like you're already connected to this particular network, and it should return true. Okay, That's good. What else we are going to say? Yeah, you're trying to connect to this particular Wi-Fi network. Then for connection, you will need the SSID and password. So this will be like what the user has written. Uh, so start the connection process. This is what we are doing there, and we are going to start a timer. Okay, this timer we are going to. Okay, this nice. I like this. So while it is not connected, okay, while we have not connected to the Wi-Fi, then we will wait for some time. In this case, 10 seconds. So we'll wait for 10 seconds. If we don't connect in 10 seconds, then we will say connection timed out. Okay. And we are going to check the status of the connection every 1 second. So think of it like in this function, we'll go inside this function 10 times, waiting for the network to connect. Okay. And if we have connected, that's well and good. If we have not connected, then it will basically print a connection timed out in 10 seconds. If you have connected, yeah, connection successful. It will return the network config. You can ask it to return a bunch of more details. So let me just do IP underscore info. Yep. And I am going to, yep, IP address is good. What else? Nah, I just need the DNS server. That should be on 3, I think. Hmm, okay. I guess this should be good. And that's it. Return true. Now, multiple ways to connect to this network. Hmm, hmm. Now, if I run this function, what would happen? Okay. That is my question to you all. Do you think it will do anything, or will it not do anything? What's going to happen? Okay, only one way to find out anything. That is, try it out, and then we can see what happens. Uh, Example usage is, oh, I you can do multi-line comments using 3 of these, if I remember. Yep, I remember Python. Nice, I like it. Hmm. Okay. Step one, let's copy it over very quickly. I have 15 minutes, so that should be good enough time. Next, I am going to not run it. I am going to do a REPL. Okay, and then Control A, Control B, and now I'm here. I can import Wi-Fi, not WebSocket, Wi-Fi underscore connect. Right, and if I do Wi-Fi underscore connect. Okay. Nope. No, that's not good. What did my README say? I can do REPL. Okay. Let's see. Scan underscore networks. Okay, perfect. Wi-Fi underscore connect dot scan networks and blah blah blah. It returned a bunch of things. Uh, but oh, there is one which is not locked. This is also not locked. EE Wi-Fi. Oh, those are the free ones. Okay, but there we go. I think it returned a bunch of those. Nice. And what we want to do is we want to connect to a network, connect to Wi-Fi. If I don't provide it anything, it says there's an error. It takes two positional arguments, but you have not provided anything. Okay, so that is wrong. So I'm going to say connect to Wi-Fi. The Wi-Fi name that I have is this one. I'm going to copy it. I'm going to scroll down and I'm going to paste it. Oops, wrong thing. Uh, is e and Wi-Fi, and then it needs the password. So let's give it the password. I won't tell you 15. Yeah, that's me being childish right there. Hit enter. It is connecting to the Wi-Fi, and yep, it has successfully connected. There we go. Connected successfully. So if I try to connect to it again, it says already connected to Wi-Fi network Peeves UAT Wi-Fi. Okay. So I gave it the Wi-Fi name, I gave it the password, and it has successfully connected. It has told me what is the IP address and what is the DNS server name, and that is done. Perfect. Okay, let me come back on screen. Any questions, anyone? So we have written a piece of code, like not much there. Excuse me. I've written a piece of code which has a lot of details. I think I can clear away some of the garbage bits from here. I don't even need to return all the Wi-Fi networks that it connects. Just first 10 is good enough, I think. Also, I have no idea what is this returning from here. I think I have messed up something. Okay. Let me also print out how to use this. Uh, Example usage, not example functions. Usage is like you have to do first connect to the REPL. So to connect to the REPL, then inside that do import Wi-Fi connect, and inside that, yep, this and this. Perfect. And I don't need this one. Cool. I think this is good enough, which tells everything that you need to know. And yep, cool. Okay, so any questions, anyone so far? I have like 10 minutes left, but I think this was where I wanted to reach. Like connecting to Wi-Fi, definitely done. We have successfully connected to a Wi-Fi network. We have successfully installed a program and ran it on our this one. We can enhance this program, of course. So we can write bits and pieces where, like, if you have successfully connected, like flash the LED like 3 times. If you fail to connect, then you switch on the LED and like flash it in other manner, for example. uh, so those are a few things that you can try out. And what else? For the time being, let me just push what, not exit, control X. So this should exit from here, and let me push what I have so far. Oh, someone asked for the check-in link. I can share the check-in link. There you go. Do check in quickly, like end of session. And while I'm pushing this out, uh, feedback form. Okay, once again. So this was session 2, or part 2 of hosting a website on ESP-32. Please do provide feedback for this session. So if you just open it, all you have to do is enter a bunch of details. Should not take much time. This was part 2 of ESP32 session. Give a rating, give a review, helps me understand like what am I doing wrong so that I can improve on it. Helps mlh know where they can provide me feedback. And yeah, it's well and good for everyone. If you like it, definitely give me some good words of commendation. That helps boost my ego. No, not boost my ego, but it helps me like feel good about myself, like, oh yeah, people do like what I'm doing. And if you don't like it, then give me any constructive criticism that you might have, that hey, if you could do it this way, this would be better. I would love to know what you all think about it. uh, I'm going to push exactly this so that you can copy it over, run it if you have an ESP32. If not, then that's fine. Then after this, I'm going to update this code to do a bunch of checks here and there, like add some checks, enhance it to look better. And yeah, that's it. Let me just push this quickly first. Git status, yep. Git add all, git commit dash m session 2. And this was wi-fi underscore connect part 1. Part 1 p small. uh, Being picky. Session 2, Wi-Fi Connect.py part 1. I'll have a Blink part 2 as well, where I'll have multiple modes of the Blink program. I'll upload that. I'll also have a Wi-Fi Connect dot instructions dot md file, Wi-Fi Connect dot instruction dot md file, so that and in that one I'll have instructions on how to run this program, and maybe a difference between part 1 and part 2 of it. uh, oh, git push. Okay, there we go. Once again, hopefully you all have filled the feedback, and if not, please do. Should not take more than 5 minutes of your time, and it will help me, help you, help MLH. Any questions, anyone? The code is right here. Okay, I will see you all tomorrow when we progress on this project, and we will upload an index HTML. We'll run ESP32 as a web server, and we'll communicate with it over the internet, over the Wi-Fi that we have just connected. Okay. Any questions, anyone? Anything? Okay. I think I've done everything very well. Thank you so much. And right after, like, you have a break now for an hour, and then you can join Stephen for Today in Global Hack Week Day 2, where Stephen will give you an overview of what has happened so far and what is upcoming. Okay, in on day 2 of Global Hack Week. Okay, that's all, everyone. Thank you so much. Happy hacking. Enjoy your time in Global Hack Week. I will see you tomorrow, hopefully, where we will continue this project. Meanwhile, keep an eye on the GitHub so that you can keep an eye on any changes that I do. Cheers. Bye bye.